Geology and surface features. Mars, the fourth planet from the Sun, is often called the red planet due to its reddish appearance, which is caused by iron oxide or rust on its surface. Its geological features are both fascinating and varied, including the largest volcano in the solar system, Olympus Mons, which stands about 13.6 miles high and spans 370 miles in diameter. Mars also boasts Valles Marineris, a system of canyons stretching over 2,500 miles long and reaching depths of up to 4 miles, dwarfing Earth's Grand Canyon. The planet's surface is marked by vast plains, immense volcanoes, and ancient riverbeds, suggesting that liquid water once flowed across its terrain. The northern hemisphere is primarily smooth, low-lying plains, whereas the southern hemisphere is dotted with heavily cratered highlands, hinting at a tumultuous geological past. Evidence of ancient lakes, river deltas, and minerals that form in water points to a time when Mars had a much warmer and wetter climate, making it a prime candidate for the search for past life. Atmosphere and climate. Mars has a thin atmosphere composed mostly of carbon dioxide, 95.3%, with traces of nitrogen, 2.7%, and argon, 1.6%. This sparse atmosphere means that Mars has low surface pressure, about 0.6% of Earth's at sea level. Despite being further from the Sun, Mars experiences weather patterns, including dust storms that can cover the entire planet. Temperatures on Mars can vary drastically, from as high as 7 degrees Fahrenheit 20 Celsius near the equator during summer to as low as 195 degrees Fahrenheit 120 Celsius near the poles in winter. The thin atmosphere and lack of a substantial magnetic field mean that the surface is exposed to higher levels of radiation from space. The planet's axial tilt of 25.2 degrees, similar to Earth's, results in seasonal changes. However, the Martian seasons last about twice as long, because Mars takes approximately 687 Earth days to complete one orbit around the Sun. Polar ice caps made of water and dry ice, frozen carbon dioxide, expand and contract with the seasons, further contributing to the planet's dynamic climate. Water and potential for life. The question of whether life ever existed on Mars is one of the most intriguing aspects of Martian exploration. Mars has extensive evidence suggesting that liquid water once flowed on its surface. Features such as dried-up riverbeds, lake basins, and minerals that form in the presence of water all indicate a wetter past. In recent years, spacecraft observations have detected recurring slope lineae, RSL, dark streaks that appear to be seasonal flows of briny water. Additionally, radar data from orbiters have suggested the presence of liquid water beneath the polar ice caps. The Curiosity rover has found organic molecules in Martian rocks, which are potential building blocks for life. The discovery of methane in the Martian atmosphere, with seasonal fluctuations, also hints at possible biological activity. While no definitive evidence of life has been found, these findings drive ongoing missions and research, fueling the hope that Mars could have harbored life in the past and might still possess microbial life in subsurface environments. Exploration missions and discoveries. Human fascination with Mars has led to numerous robotic missions aimed at uncovering its secrets. The first successful flyby of Mars was achieved by NASA's Mariner 4 in 1965, which provided the first close-up photos of another planet. Subsequent missions, such as Viking 1 and Viking 2 in the 1970s, conducted experiments searching for signs of life. The 21st century has seen a resurgence in Martian exploration, with rovers like Spirit, Opportunity, and Curiosity traversing its surface. These rovers have analyzed rocks, soil, and the atmosphere, sending back invaluable data. The Mars Reconnaissance Orbiter has provided high-resolution images of the planet, revealing intricate details of its terrain. The InSight lander, which arrived in 2018, has been studying the planet's interior, providing insights into its seismic activity. The most recent addition, the Perseverance rover, landed in 2021, equipped with advanced scientific instruments to search for signs of ancient life and collect samples for potential return to Earth. These missions have significantly advanced our understanding of Mars and laid the groundwork for future human exploration. Prospects for human settlement. The idea of human settlement on Mars has captivated scientists, engineers, and the general public alike. Challenges abound, including the harsh environment, radiation exposure, and the need for sustainable life support systems. However, advancements in technology and growing interest from both government space agencies and private companies like SpaceX are bringing this vision closer to reality. Concepts for Mars habitats involve using local materials for construction, such as 3D printing with Martian regolith. Developing closed-loop life support systems that recycle air, water, and waste will be crucial. NASA's Artemis program, aimed at returning humans to the moon, is seen as a stepping stone for Mars missions, providing experience in deep space living. The prospect of utilizing Mars resources, such as extracting water from ice and producing fuel from atmospheric carbon dioxide, is also being explored. While establishing a human presence on Mars presents significant challenges, it holds the promise of a new frontier for scientific discovery, technological innovation, and possibly the survival of humanity as a multiplanetary species.